Hi guys, this is part 2 of the Twitter clone application tutorial series where I show you how to build a Twitter clone application. So here are some screenshots of this application. It has the core functionalities of Twitter. You can post tweets, log in as different users, use OAuth to log in, and it's built with React.js, GraphQL, Node, and MongoDB. So let's begin with setting up the folder structure or the project. Basically, just go to my URL here. I'll post this in the video description. Go to the basic structure branch, clone my project, and then open it up in your Visual Studio Code code editor. And then we're going to run npm install on the server. So cd into server and then run npm install. And then what we're going to do is we're going to import some stuff, and all this stuff can be taken from the source code. So if you'd like to skip ahead, feel free to do so. The link to the source code is in my video description. So let's start with the tutorial. I'll cover the important points. I'll cover or type along with the important points, and I'll copy and paste the trivial points, so in order to save some time. So right now we are typing, or we are creating a big int scalar type. And basically a scalar type is, if you think of a tree, and you think of GraphQL queries as analogous to that tree, object types would be representing the trunk of that tree, and scalar types would be the leaves of that tree. So these are kind of end results. And some of these examples are numbers, strings, stuff like that, Boolean. And what we're doing here is we're defining a custom scalar type called big.int. So this is built into several languages like Java, but in Kotlin they don't have a native type for big.int, so we have to define it ourselves. And here's how we do that. So we're just typing out some stuff here. No, return no. Okay, so here we're typing out some required methods for this type, and this basically represents the big.int scalar type. Next, we're going to define a server. And we're going to use new GraphQL server. And this server is basically a server that exposes data as a GraphQL API, so that client applications can query for data. And the way we set up this server is by doing something like this. So right now we're defining some resolvers. I'll get to what resolvers are very soon. But and we're defining our type definitions file. which we'll add to very soon. And then we define Mongoose. So we give Mongoose a connection URL to connect to the MongoDB instance or database instance. Use define. And now we're defining an error condition. So in case this MongoDB connection errors out, here's what we need to do. So make sure that MongoDB is running. Process set. Set server start and now we're telling the server to start on port 8081. If you're wondering why I picked 8081, it's because I have this Jenkins server running on 8080, and I have to pick a different port. So if you want to pick 8080, you feel free to do so. Okay, so now our index.js file is complete. And if you're wondering what Mongoose is Mongoose is a JavaScript library that defines or that creates a connection between MongoDB, our database, and GraphQL server, which is our backend. And now let's go to our database models file. We can delete this file, by the way, db.js, not needed. Now let's check out models. So let me bring up some code here. So here we're going to add some schemas, and basically we're going to add the user schema first. And if you're wondering what a schema is a definition of a model. So we're defining all the attributes, the fields that our model will contain. And in this user schema, we're defining the first name, last name, email, age, and then a tweets field. In this tweets field, we're defining the tweet schema inside it. So we'll say Mongoose schema, and inside it we're going to define the tweets. So we have the body, published, author. So the author is the person who published the tweet. The body is the message of the tweet, and then finally we have comments. So every tweet can receive comments, and a comment is basically very similar to a tweet in that it has an author, it has a tweet, which is a tweet schema, so it encapsulates tweet, and it has a text which is representing or similar to the body. So they're very similar, just a user can have a list of tweets, and that list of tweets, each individual tweet in that list of tweets can have a list of comments. So hopefully that makes sense. Next, we can have comments as well. So a user can produce comments, they can write comments, and that will be stored in comments array. Next we have password, password salt, password reset token, and password expires. These fields are related to password storage, so basically we can't store a plain text password in the database. We need to hash that, and the way we do that is by using bcrypt library, which we have defined over here. We're going to hash that password using the password salt, and then we're going to store the hash password and the salt as fields in this user schema. And then the reset token and the expires are used to reset passwords if the user needs to do so. And next, we're going to define a middleware function. So a middleware function is something that will be executed, a function, a piece of code that will be executed prior to a certain action taking place. In this case, prior to the event save, prior to saving our model to the database, this function we define here will be executed. And we need this function here in order to hash our password. Basically, when we try to save the user instance to the database, that password is not hashed. It's just a plain text password, which is extremely insecure. In order to get around this, in order to hash that password, we're going to use bcrypt and this middleware function to hash the password and then store it, and store the hash password instead of the plain text. So right here we're saying gen salt, generate the salt, and then we're saying hash user.password salt function next. So we're going to generate a salt, make sure it's 10 digits long or 10 rounds, and then we're going to hash that password. We're going to take the plain text password, apply the salt, and then say hash equals user.password, and then password salt equals the salt here. And then we say next to proceed with the save event. So now that that's completed, there is one additional thing we have to do. We have to use Mongoose Paginate, and this is used to paginate the response received from any data source. So when we receive a response from the database, we're using Mongoose Paginate to paginate the results, so it looks, or it's more organized. Tweet schema. So now we're compiling our models using the model method, as we see here. Schema. Mongoose. And finally, we're going to export the user. We're going to export all these fields, or all these objects rather. Mongoose. Okay, so now that the models have been defined, we can move on to our schema. So in the schema, we're defining our GraphQL types. And GraphQL types are basically what define the GraphQL queries, the mutations, the subscriptions, things like that. So let us start by importing big int and then importing type query. And now we're going to define some queries. So a query is basically something that fetches data. So let's see here. So a query type is used to fetch or read values from the database. If you think of traditional HTTP requests, think of queries as GET requests. So they just get stuff. They don't manipulate data. They don't create data. They just get stuff. Users and tweets. And don't worry, I will explain all of this shortly after I finish typing. So now we have a series of queries, and query login, input, login, response, user, tweet. So what we're doing here is for tweets, we're getting a list of tweets, and for users and tweets, we're sending a list of users and tweets. For login, we're getting the user login input. So now you're probably wondering, what is a user login input? So let me show what a user login input is. So it's an input field, and it's going to consist of an email, which is a string, and a password, which is a string. So this is basically just making it neater. It's just a way of passing in parameters to this function. And as output, we're going to issue a login response object. And a login response object is defined by this login response. So it has a user ID for user first name token, token expiry date. Next, we have type mutation. And a mutation is these types are used to change the state of our data, our data contained in the database. So they're basically creating data, modifying data, manipulating data, deleting data. They're analogous to HTTP post, put, and delete requests, and we use input types that can be passed as parameters into these mutation methods. These input types contain fields that are needed by the mutation methods, and let's get started on creating them. Create user input. Delete user. And let's speed things up here so we can now explain. So create user, pretty self-explanatory. We're creating a user. Update user, we're updating users to create. So these are basically CRUD operations on user, tweet, and comment. And notice we're all using unique input types. And this will be defined shortly. So now, next we move on to the third and final type of GraphQL objects, and this is subscription. So subscriptions are types used by the server to send specific data to its clients when a specific event occurs. If you want to think about a YouTube channel analogy, every time you subscribe to a YouTube channel, whenever the channel owner releases a new video, you're notified of that event in your subscription feed because you subscribe to that, right? So that's basically what is similar to this. It's basically you subscribe to an event, and the subscriber will get a response every time the issuer issues or the publisher issues a event. These are also known as pub-sub systems, publication and subscription systems. And so these are the big three types: queries, mutations, and subscriptions. Everything else I will paste here, and this is all grabbed from my source code for the sake of saving time. So you can see input types defined here, and these are the scalar types I was talking about earlier. So string, int, boolean, ID, and as you see here, we're using big int for an ID because we don't want a normal int because they're quite small, or not quite small, but relatively smaller than big int. And since we're going to be issuing a lot of login responses, we want a big number to represent the ID field. So we use big int here. So you can grab all this source code in my GitHub repo down in the video description. So don't feel like you're missing out or anything. Just if you have any doubts, just leave a comment. And next, let's move on to the resolvers folder. So resolvers are basically functions that fetch data from a data source when initiated by a schema field in the schema.graphql file. So give me a second here. So we have query.js. Oh, it already exists. And basically, we're going to create a query object. And if you want an analogy from object-oriented programming, think of the types defined in the schema file as interfaces and resolver objects as concrete classes that implement those interfaces and define concrete implementations for those schema methods. So we have query right here, and then we have tweets. This is a method, and this will be defined right here. So this will be given a concrete implementation in our resolvers. So that's what resolvers do. They resolve methods or define concrete implementations. So we have tweets here. So we're querying the Mongoose model. We're saying find all tweets and then return it. Here, user and tweets. We're saying find all users and tweets and then return an object containing users and tweets. Next one is a bit lengthy, but here it is. So login. So this is a query, but basically what we're doing here is we're using the email passed in to find if a matching user with that same email exists. If that user exists, great. Now we're going to get the inputted password and the user's password that's found in that instance. Then we're going to use bcrypt to hash or compare the inputted password with the current password in order to see if they entered the right credentials. And if it's true, if it's a match, then we use a JWT token and we send the user ID, email, password, and a secret in the form of JWT token or a token in the form of a JWT token as a response. A JWT token is a method of providing proof that a user has logged on to the application. Traditionally, we've used sessions, but nowadays it's pretty standard to use JWT tokens because they offer increased security. And we're using this token to say, okay, this user has provided this token. Every time they want to visit a certain page in the application, they have to present this token to the server, and the server will validate that token to see if they have authorization to access those pages. If not, if they enter an invalid password, then we just say invalid password, please try again. So that's the query page. And now let's move on to the mutations.js file. So mutations, in mutations, we're saying const mutation. And we forgot one thing here. We need to export query as default. Okay, and then over here, async create user. So mutations are creating stuff or modifying stuff or deleting stuff. So in this case, we're creating a new user. First check if the email exists. If the email exists, don't create a user, throw an error. So we want all our emails or all our users to have unique emails. We don't want users with duplicate emails. Then create a new user instance with the fields provided. Save the user. So when we say save, that method we defined over here, the pre-save hook is being fired, and this will automatically hash the password right there. And then we're going to return a result. Result is going to be this user instance. Or if it errors, then we're going to return an error. Next, we're going to provide the concrete implementation for deleting a user. So we have find the user using the ID. If it's not found, say user not found. Then we're going to delete the user using some unique syntax here. So we're using splice to delete users. It basically changes the contents of an array by replacing elements. And we're basically going through each tweet in this array, and we're deleting all tweets that were sent by this user. So when we delete a user, we want every record to cascade. Cascade just means that when we delete a user, let's say we have tweets sent by that user, we want those tweets to be deleted as well. Let's say we have comments made by that user, we want those comments to be deleted as well, just because they're linked to that user. So everything that user did, it will be invalidated and deleted. So that is what this logic is doing right here. And then we're returning the deleted user. Next up, we have update user. So we're finding the user by their ID, and then we're updating each of their fields. So email, name, age, with the provided or update the new value to be updated. Next, we're calling create tweet. And this is pretty self-explanatory. So again, we're creating a tweet, and we're finding the user first. So the tweet was issued by a user. That user first has to be found. And if that user is not found, then it's not valid. But once the user is found, then the author is that user. And if you want the tweet to be published, so publish means that the tweet needs to show up on the client side, then we save it and we say all tweets, and then we use our subscription method, get all tweets, to issue a subscription event to our listeners. So as this comment says, it's simple publish and subscribe API. And it receives a publish command from the application logic, and it pushes that to whoever's listening. And then we have some error catching code right there. Next, we have delete tweet. And we're just deleting a tweet right now, finding that tweet using the ID, and then we're saying comments, filter the comments to find a tweet with the same ID. So comments that are linked to that tweet. So let's say you have a tweet along with some comments for that tweet. If that original tweet is deleted, so those comments also have to be deleted, which is what is happening right there. And we're issuing an event saying that the tweet was deleted to our subscribers, and then returning the tweet. So now we have quite a lengthy method called update tweet. And basically what this is doing is we're saying find a tweet by the ID, if not throw an error. If the body is a string, then update. If the body is a boolean, so basically validating or checking if the published data or the received data has these fields. If it does, then we're going to update them. We have publish, and we're issuing lots of events here. So we have deleted and then created, updated, and if it's published, then we issue a published event. And then if it's author, it's not undefined, then we set the author to the passed in value, and then we say found tweet. And then finally we export our mutation object. Next, let's move on to the subscription.js file. And basically this one's considerably shorter. So we have our subscription and we have just two. So get all tweets and user. And so hold on here. So if so both get tweets and user methods are executed when events of the type get all tweets and user are executed. These methods return new events of type get all tweets and user to whoever is currently subscribed to these events. So that's what pub/sub async iterator is doing. It's just issuing a event to those subscribers. And now let's move on to the tweet.js file. Over here, we're defining a tweet object, and this is used just to fetch the author. So we want to find the author by the ID and then return that. So quite simple here. Now we want to create a new directory. This might already be created, but we want to create a new config directory and an environment.js file. Inside it, we want to create a new variable called MongoDB connection URI, and then paste our MongoDB connection URL as a value. This is done in order to connect to the MongoDB database. Now, if you're wondering where to find your MongoDB connection URI, you basically have to log in to cloud.mongodb if your MongoDB is in the cloud, and then click connect. So I'm connecting with MongoDB Shell. I already have MongoDB Shell installed, and we just copy this shell, or this is our application string. Yeah, so this is the application string that we actually, I'm not, yeah, no, that's not right. Yeah, so this which should be the application string. So your username, password, you'll have to substitute for whatever is relevant to you, and then your database name. So that'll have to be changed as well. And then you just use this connection string and paste it as a value in there. If you're confused about username and password, try installing MongoDB if you don't have it installed. If you have it installed and you don't know username and password, just uninstall it and reinstall. So yeah, you can install MongoDB, and then they'll let you set the username and password. So that should be fine. And then once you set up that connection URI string, we can connect with MongoDB. So that concludes our server-side server application setup. Yeah, and that's it. If you have any comments or any questions, please let me know in the comments below, and I'll try to get back to you if I have time. And thanks for watching my video. If you liked it, you know what to do. See you in the next video where we cover the client application. Thanks again, and have a great day.